AIP Chemistry from Chem 10. Classification of substances. Elements. They're only made from one type of atom and cannot be broken down further. Compounds. Consist of two or more different elements chemically bonded together. Mixtures. Combination of substances that are physically mixed and separated through physical separation techniques. Number 1. T concepts on elements. Each element is composed of atoms with the same number of protons. There are currently 118 known elements, and this is the periodic table. Number 2. T concepts of compounds. Be separated through chemical reactions, but not through physical methods. They have different properties from the element they're made out of. For example, water molecules. Water has a different property than oxygen and hydrogen, which are the elements that make water. 3. Key concepts on mixtures. Can be either heterogeneous, compounds are visibly saturated, or homogeneous, compounds are evenly distributed. Can be separated through techniques like filtration, distillation, chromatography, or evaporation based on their properties. In future videos, we can talk about separation techniques. Use of pure substances and mixtures. Pure substances, like elements and compounds, have fixed melting and boiling points. They also have specific physical and chemical properties unique to the substance. Mixtures. Classified as homogeneous or heterogeneous. Homogeneous being uniform composition and heterogeneous being non-uniform composition. Atom's structure. Nucleus. Places in the center of every atom and contains individual protons and neutrons. Protons being positively charged, the same as the number of electrons. Neutrons being negatively charged. Both protons and neutrons having a relative mass of 1. The relative mass is important to compare the sizes of protons and neutrons with electrons. Electrons are 2,000 times smaller than protons and neutrons. That's why it's important to know the relative mass of neutrons and protons, which is 1. Electrons are also negatively charged. Atomic number presents the number of protons in a periodic table, also presents the number of electrons in an atom. Mass number presents the total number of both protons and neutrons. This is a nucleus, protons being positively charged and neutrons being neutral, and we have the electrons which are moving around the energy level. Next we got amount of oxygen in the periodic table, where we can see the element symbol in the middle and we can see the name underneath. There's also atomic number, which is showed with the letter Z, and in this case for oxygen the number being 8, showing the number of protons and electrons in oxygen. At the bottom of the box we got the atomic mass, which in this case is 15.999. The periodic table. Relative atomic mass of elements refers to the weighted average mass of an element's atoms compared to the mass of an atom of carbon-12, as we saw before. Atomic mass refers to the number of protons in an atom nucleus, determining the element's identity and its position on the periodic table. Mass number refers to the total number of protons and neutrons found in an atom nucleus. Isotopes refers to the elements which share the same number of protons but not have the same number of neutrons. Same atomic number, different atomic masses and mass number. Groups, periods. Groups in the periodic table are the vertical columns containing elements with similar chemical behaviors due to having the same number of electrons in the outer shell. So groups care about the number of electrons in the outer shell. There are only 18 groups in the periodic table. Periods, horizontal rows, each containing elements with the same number of electron shells. So periods care about the number of shells in the elements. And we only have 7 periods in the periodic table. Ionic bonding involves the transfer of electrons between two atoms, resulting in the formation of cations in anions that are held together by strong electrostatic attraction. Between a metal and an element at high melting and boiling points due to strong electrostatic force, the two elements become neutral. Giant ionic lattice shows a three-dimensional structure composed of a rotating pattern of cations and anions held together by ionic bonds. Conduct electricity when molten or dissolved in water because of the free ions that get released. So here we got an example of sodium and chlorine, sodium being a metal and chlorine being a non-metal. Sodium has 1 electron in the outer shell, chlorine has 7 electrons in the outer shell. So by sodium giving 1 electron to chlorine, they both achieve a stable electron configuration, covalent bonding, when atoms share electrons to achieve a more stable electron configuration. This happens to fill the outermost energy level of atoms, can be single, double, triple, etc. based on how many electrons they are sharing, having a strong electrostatic forces, not able to conduct electricity because they have reached a stable electron configuration. Giant covalent structures are three-dimensional networks of atoms sharing covalent bonds, forming strong structures. And here we got an example of hydrogen and chlorine, electrostatic attraction in between positively charged electron and negatively charged electrons. Atom 1, which is a metal, we can see that the electrons in the outer shells are positive, while atom 2, which is a non-metal, has negatively charged electrons in the outer shell. The electrostatic attraction is between the electrons in the outer shell of atom 1, which is positive, and the outer electrons in atom 2, which are negative covalent bonds, only happen between two non-metals, meaning that the electrons in the outer shells are only negative. The attraction between the outer shell electrons and protons are what makes the electrostatic attraction.